Okay, I'm just going to do a little bit of explaining about this puzzle activity. If you don't have blank pages in your packet, just grab some blank pages. This is just to make sure and to try to help you understand how to follow the law of conservation of mass. So there's a couple helpful hints. Coefficients represent the number of molecules, and when we're looking at the shapes will not be touching. So for example, if I have 2 potassium molecules, and I'm representing them using these squares, these boxes, they won't be touching, okay? If I have subscripts, so for example, let's say that I have calcium chloride, so I've got a subscript right here, then subscripts represent the number of atoms, and if we're drawing shapes, the shapes will be touching. So for example, on this one, let's say our calcium is a yellow color, and let's make our chlorine a purple color. These will all be touching because they are a formula, and there's 2 or more atoms, so they're going to be touching. Okay, so hopefully that will help with that scenario about what the shapes are doing when we're having a molecule or subscripts. Okay, so let's do this first example together. Okay, the rules. We cannot change shapes. We cannot take a shape out. So that means we can't just like get rid of this shape right here, or we can't get rid of this shape. We have to keep what we have because these are correctly written formulas. The only thing we can do is add duplicates of any shape. And we can do this on either the reactant side, this is the reactant side, or we can do it on the product side. And the goal is to keep the number of colored blocks on both sides of the equal sign the same. Okay, so let's go ahead and get started on this. So first of all, we've got 2 blue atoms on the left side. On this side, we only have 1 blue atom right here. So in order to make this work, we've got to add more on this product side. So I'm going to go ahead and add this blue. But because it's touching this other atom, we have to add that as well. So this gets added as well. Okay, so this is the duplicate that I'm talking about. We can add duplicates. Okay, now you notice that instead of having 1 blue, we've got 2 blues on this side. So now our blues are the same. Let's look at the whites. So on here, the whites, we've got 1, 2 white squares. Over here now we have 1, 2. So both sides have the same number. So now we have a balanced chemical equation. Now this is what this looks like. If we go to the next slide, here's what it looked like. First, it wasn't balanced. Then we balanced it by adding 1 more HCl. So what happens here is we notate this by using coefficients. So this is a coefficient right here. Oh, sorry, you can't see the screen. Okay, there we go. Okay, this is a coefficient. So because we have 2 HCl's right here, we need to show that we have 2 by putting this coefficient right here. Notice how on H2, these boxes are touching. That's a subscript. And so they're touching because they're in a formula. That's the correct chemical compound. Right here, we've got a subscript of 2. Again, these 2 are touching. Okay, you only have 1 of these hydrogens and 1 of these chlorines, but we don't write 1 because it's completely redundant. It's already being represented by just having the H2 and the Cl2 there. So this complete equation has 1 molecule of hydrogen, 1 molecule of chlorine, and 2 molecules of HCl. We can also say that it has 2 atoms of hydrogen by looking at this coefficient. It has 2 atoms of chlorine. And this, if we distribute this 2, we have 2 atoms of hydrogen and 2 atoms of chlorine. So this is now a balanced chemical equation. Okay, let's do another example. Let's look at this one right here. Okay, I don't know why that did that. Let's go back. Sorry. Okay, So this next one, notice how we have one purple on the reactant side, and on this side we have two purples. So the only way we can get another purple is to add one on the reactant side, but notice how nothing's attached. So we have to keep this separate. Okay, but we're going to add this purple box right here, which is representing a sodium atom. Okay, now let's look at our red. Our red has two. Okay, you kind of notice that's an outline. And they're touching. We have two rectangles. These are representing the O2. On this side, we only have one oxygen. So in order to get two, again, what we're going to have to do is we're going to have to add another molecule, just like we have on the product side. So this is sodium oxide, so we have one red and the two purples. Okay. So now if we look at things, instead of having one oxygen, we have 1, 2. So I'm going to cross that out. We now have 2. And then we need to make sure that now our purple, which is representing oxygen, is the same as well. So again, on this side, we've got, instead of having 1, now we have 2. This side we have 1, 2, 3, 4. Okay, so now our oxygens aren't balanced. So what we're going to have to do, our sodiums, our purple are sodiums. So now what we're going to have to do is add 2 more purple boxes, which are representing the sodium, on this side. Again, we're not touching them because in this formula up here, we don't have coefficients. And we don't have another element. It's just by itself, and so they're not touching. So now we have 1, 2, 3, 4 sodiums. On this side we have 1, 2, 3, 4. Our oxygens we have 1, 2, 1, 2. So now this is a balanced chemical equation. So if we were to write our coefficients for this equation, we're going to say, oh, we have 1, 2, 3, 4. So we're going to put a 4 in front of the sodium. Our O2 is together, so that's representing one molecule, so we're not going to change that. And we've got 1, 2 of our sodium oxide, so we're going to put a 2 in front of that product, that sodium oxide. And that would be your chemical equation. So if we look at this a little bit nicer, here's what it looks like. There's our balanced chemical equation. Oops. Sorry, let's go back. Our balanced chemical equation. Oh my goodness, I'm making a huge mess. Oh, go back. Okay, there we go. Our balanced chemical equation is showing 4 sodiums. 1, 2, 3, 4. 4 on this side. 1, 2, 3, 4. And that means 4 right there. 2 times 2. Our oxygen, we're seeing 1, 2. That's where that comes in. And over here, we're seeing 1, 2. And that 2 distributes to that oxygen, so we have a balanced chemical equation. And it's following the law of conservation of mass when it's balanced. Okay, let's do one more. So on this one, we've got 2 reds, 1, 2. And notice that these are connected because the boxes are touching. Okay, on the right side, product side, we've got 2, so that's lovely. On the reactant side, we've got 2 black squares. On this side, we only have 1. So the only way that we can do this is by taking and adding a whole nother compound right here. We have to add that again. So we're going to draw another black. And because it's being bonded, we have to draw the red with it. Okay. And now... Okay, now what happened is now we have 1, 2 black squares on the side. We still have 1, 2 on the reactant side. And then our reds, 1, 2, 1, 2 on the product side. So now this is a balanced equation. So if we were going to write this out, okay, I don't think I have one on here. Let me just double check this really fast. If we were to write this out, what we just did, remember what we did here, we added another product. So right here, we added this. Okay, let's say that this is hydrogen, so we'd have H2 here plus oxygen, and this would be water. And because we have 1, 2 of them, we're going to put a coefficient of 2 right there. Okay, so again, let's double check this. You've got 2 hydrogens, 1, 2. Over here, we've got, oh, see, this is good. We caught something. We have 2 times 2, which is 4. 1, 2, 3, 4. So that's not right. So what we have to do here is we have to add another hydrogen. Ooh, good thing we caught that. This is why we double check. Okay, we're going to add that. So now we have 1, 2, 3, 4. 1, 2, 3, 4. Now we have 2 here, so we have to put a coefficient of 2. So 2 times 2 makes 4 atoms total. Here we have 2 oxygens. Here's this 2 distributes to the oxygen, so we have 2 oxygens there, and we have 1, 2 there. Okay, so our final equation would be 2H2 right there, 1 O2, and 2 waters. So it's a good thing that we checked that to make sure that it was balanced. I hope this helped. Continue to do the rest of the puzzles on here, and if you have any questions, let me know. I hope I see you guys soon. Bye.